Hello and welcome to our lesson on rounding and estimating, which are two of the most useful skills you could pick up in a math class because they kind of carry over to just about anything. So what does it mean to round a whole number? Well, when you're rounding a whole number, you're basically approximating or estimating its value. So the rounding and estimating go hand in hand. And why is my highlighter turned on? I don't know. So when you're approximating or estimating, those are interchangeable words there. You're trying to round a number because a rounded whole number is often easier for us to use. It's probably easier for us to understand and definitely easier for us to remember. So a rounded whole number is often easier to use, easier to understand, and easier to remember than the precise whole number. Now, if you're talking about a number like 9 versus rounding it to 10, I mean, that's not significant. But if, for instance, let's say you looked up the population of Missouri last year, you would find that the population of Missouri was 6,063,589. And then a week later, I said, hey, you looked up the population of Missouri. What was it? Well, you probably wouldn't remember that exact number, but you could estimate and say, hey, the population, it was about 6 million. So it might be easier for us to just understand that it's ballpark 6 million, definitely easier to remember that it's around 6 million. So 6 million, geez guys, 6 million would be an estimate that would be easier for us to remember. Is a reasonable estimate. Okay, and that is a rounded version of our 6,063,589. Okay, now that is rounded to a specific place value, which is what we're going to practice doing. And there are a couple ways to do it, but just to wrap your brain around the concept, since it may have been a while since you've rounded to specific place values, I want to show you how to round using a number line to help. So remember that all whole numbers, they're part of that real number group that we talked about, which means all numbers can be plotted or graphed on a number line. And we graph a number on a number line by darkening in a point to represent its location on that number line. And depending on the place value that you're trying to round to, you can break that number line into different increments. Generally, you're going to break it into increments that are 1 less than your place value. So, for example, if you're going to round to the tens place, you're going to use increments of ones because the ones place is right below the tens place. If you're going to round to the hundreds place, you're going to break it into increments of tens because that's one place value below where you're rounding. So the increments will be one place value below where you're rounding. And this might seem a little tedious, but this is just to make sure we feel okay with the concept, and then I'll show you the quicker way to do it. Okay? So let's say, for instance, we were trying to round 36 to the nearest tens place. Okay, so 36 to the nearest tens place. Well, this is the tens place, but again, on a number line, if we're going to round to the tens place, what we need to know is, are we closer to the 3 or the 4, or let's break this down. So if we're going to round to the tens place, we're going to break this number line into increments of ones because ones are right below the tens. So I'm going to start with, and I'm just going to arbitrarily say that this is 30 right here. This would be 31, 32, 33, 34, 35, and then 36, 37, 38, 39, and 40. So I have a lot more space than I really need on this number line, but I was trying to pick a generic picture to put into our notes. Okay, so let's look at where 36 is at. Okay, 36 is right here. So there's 36. When I say round it to the tens place, the tens that the 36 is between 30 and 40. Okay, so 36 is between 30 and 40. So is 36 closer to 30 or is it closer to 40? That's the question. And since 36 is closer here, we're only 4 units away here, whereas we are 6 units away here, we are closer to 40, we would round 36 to 40. So 36 rounds to 40. Okay, when we're rounding to the tens place. Okay, we're looking for the nearest 10. And the nearest 10 is not the 3, it's the 4. Okay? Let me show you that again here. Let's say we're rounding 52 to the nearest 10. So I'm going to start with 50 this time. So I'm just going to plop 50 down here. 51, 52, 53, 54, 55, 56, 57, 58, 59, 60 is going to be good because 52 is between those two markers. So again, if we're rounding to the 10, we want to label our number line using ones. Okay, so now I'm going to plot 52 on my number line. 52 is right here. And then I just got to figure out which of those markers is it closer to. So 52 is only 2 units away here. So it's 2 units away here, where it is 8 units away from the next 10. So 8 units away here. And gosh, that is sloppy. I'm trying to write small here. Okay, 8 units away here. Some of you might be thinking, well, it's closer to 55, but 5 is the same ones, so we want to look at the 0 after the place we're trying to round to, okay? So let me get rid of that. Since we are closer to the 50 than we are to the 60, then we're going to round this to 50. So 52 rounds to 50, okay? And in the first one I showed you, since we went up to the nearest 10, we say that is rounding up. Okay, we round it up. And then in the previous here, the 52 was closer to the 50 than the 60, so we say we rounded down. Generally, it's rounding up if the number you've rounded to is larger than your number. It's rounding down if the number you've rounded to is less than your original number. So we rounded down on this one. Okay, let's try it again. This time, we're gonna... Oh no, yeah, still tens place. I'm getting ahead of myself. So excited about rounding. So we're gonna round to the other ones say round to the tens place, or this one said round to the nearest 10. The wording means the same thing, so the tens place or the nearest 10. So the verbiage is the same there. We're still going to use increments of 1 on our number line. This time we're trying to round 25. So I'm going to start with 20, and then 1, 2, 3, 4, 25. And actually I'm going to leave that blank this time. 5, 6, 7, 8, 9, 30. Those are my tens, and 25 is right smack in the middle. So if 25 is in the middle, and I said, where are we going to round? Well, we're asking generally which of these it's closer to. Well, it's 5 units away here, but it's also 5 units away here. So it's not closer to either side. And so just as a general rule of thumb, again, to keep things consistent, this is why a lot of rules were developed in math, we generally, as a rule of thumb, round up when we're exactly in the middle. So if we're looking at a 5, we will round that up. So even though the distance is exactly the same between the 20 and the 30, or from 25 to 20 or 25 to 30, we will round up when it's in the middle. So we're going to round 25 rounds up to 30. Okay? Now we're going to try a different place value. So the next one, we're going to round to the hundreds place. So if we're going to go to the hundreds place this time, one place value below the hundreds would be the tens. So we're going to use increments of tens in our picture here. So we have 100, and then 110, 120, 130, 140, 150, and then 160, 70, 80, 90, 200. And I suppose I could have made smaller number lines here, okay? But since we're rounding to the hundreds place, again, I'm looking at 100 and 200, and I'm going to go in increments of 10. So when I try to plot my 113 in there, it's not going to be an exact spot, but this is 110 right here. So 113 is going to be right about in here somewhere. So 113 is here, and I could see that's really close to the 100 and really far away from the 200. So if I said round this to the nearest hundreds place, it's absolutely closer to the 100 than it is to the 200. So we would round down to 100. Okay. Let's try that again. So we're going to round to the nearest 100. Again, nearest 100 or hundreds place, same wording there. So I'm going to use increments of tens. And we're at 167, so we need to know which 100 is it closer to? Is it closer to the 100 or is it closer to the 200? So I'm going to put 100 on my number line here. And then 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. Okay, so which of the hundreds is it closer to? And 167 this time, so this is 90, 80, 70, 167. 90, 80, 70, 60 is going to be like in here somewhere, approximately. So there's 167-ish, okay? We can see from our number line that it is absolutely closer to 200 than it is to 100. So we're going to say this rounds up. We're going to round up to 200. That is the 100 that it is closer to. Okay? And then again, let's see, we're rounding to the hundreds place. So which 100 is 150 closer to? Is it closer to the 100 or 110, 20, 30, 40, 50, 60, 70, 80, 90, 200? Which one is it closer to? Well, 150, 10, 20, 30, 40, 50 is right smack in the middle. So it is the same distance from both of those, and when it's right smack in the middle, we will round up to the next 100. So we're going to round up to 200. That is the rule when it's right in the middle. Okay? Now, the graph is there again to try to help you visualize what you're doing, and maybe that's the concept that's going to happen in your head, but in reality, it's going to be more efficient for us to do this without having to make a number line. And some of you are probably thinking, okay, I'm ready, it's fine. So rounding without a number line. What you're going to do is locate the digit that is to the right. What digit is to the right of the place value that you want to round to? And I made a typo there, so it says right to. It's supposed to be round to. And what we're going to do is if that digit that is to the right of the one we're rounding to, if it is 5 or greater, that's when we're going to round up. And so we round up by adding 1 to the digit that's in the place value we're rounding to, and then that digit and everything else to the right of it gets replaced with a 0. And that probably sounds really complicated, but when I show you the example, hopefully it will come together. So that's basically the process of rounding up. Okay, and if our number that's next to the one we're trying to round to, if that number is less than 5, that's when we round down. So we will replace that number and every other digit to the right with a 0. Okay? So that's basically, again, that is our rounding down process. And I was trying to put it succinctly in words, but I don't know if that sounds I don't know if that sounds any less confusing, but let me show it to you and hopefully it will make sense. And I apologize if you can hear my dog. He is harassing me by crying back here. Alright, so 568, it says to round to the nearest 10. Okay, so if we run around to the tens place, let's identify where that is. That's the number I'm trying to round. If that's the number that I'm rounding, what I have to look at is the digit to the right of it. So I'm really focused on this digit here. And if that digit is 5 or greater, we're rounding up. If it's less than 5, then we're rounding down. So 8 is clearly bigger than 5. We will be rounding up. And when we round up, basically our digit gets replaced with 0, and we add a 1 to the place value we're rounding to. So when we want to round up, so 8 is bigger than 5. This is just for your notes, right? It's bigger than 5, so we round up. And we round up by adding 1 to 6, and then replacing 8 with 0. Okay? With 0. So because we're rounding up, a 1's going to get added here, and this is going to become a 0. And so we end up with 570. All right, now that might be more complicated than it needs to be. Maybe you're looking at this and you're going, okay, I'm looking at the number 568. If I have to round to the tens place, the question is 68 closer to the 6 that's in the tens place, or is it closer to 7 in the tens place? So is 68 closer to 60, or is it closer to 70? Well, it's closer to 70, so we're going to make that 68 a 70, so it's 570. Okay? Let me show you again. So we're going to round to the nearest 1,000 on this one. So in the thousands place is an 8. If I want to round that number, I have to look at the one that is to the right of it, okay, and decide if we're going to round up or if we're going to round down. So 3 is definitely less than 5. 3 is less than 5. So we round down. Okay, round down. And we round down by just replacing that 3 and everything after it with zeros. So replace 3, 6, 2 with zeros. Okay, so our number becomes 278,000. That is our number that is rounded to the nearest 1,000. But the question is, if we're rounding to the thousands, okay, think about this question. Again, it doesn't have to be this complicated. Is your 8,000, this whole piece right here, okay, is that number closer to the 8 in the thousands place, or is it closer to the 9 in the thousands place? So is it closer to 8,000 or 9,000? Well, 8,362 is definitely closer to 8,000 than it is to 9,000, so 8,000 it is. Okay? Hopefully that's making sense. Oh my gosh, I'm sorry if you can hear my dog. He is driving me crazy. Okay, next one, we're going to round to the nearest 100. So if we're going to round to the nearest 100, we're looking at the digit that's in the hundreds place. And to the right of it is a number less than 5. So again, we're asking ourselves, is 304 closer to 300, or is it closer to 400? Well, it's definitely closer to 300. So when we round down, we replace that digit that we're looking at and everything after with a 0. So 72 stays, 3 stays, but the 0 and 4 are going to become zeros because we said it's closer to 300 than 400, so 300 instead of 304. And so 72,300. Okay. Next, we're looking at rounding to the nearest 100 again. So to the nearest 100, we're looking at this guy here. So that 9 is what we want to round, and to know where to round, we look at the next digit, okay? That's an 8. That's bigger than 5. That's telling me to round up. Because 982, what we're asking is it closer to 900, or is it closer to 1000, which is 1,000? Well, it's closer to 1000 or 1,000 than it is to 900. So we know we're going to round up. But this one's kind of tricky because if we try to round up to 1,000, I can't put 1,000, that's a 4-digit number, in that 3-digit spot. So 982, okay, technically rounds up to 1,000. So what do? Well, normally we would just be adding a 1 to the 9 here. Since that makes a 10, we're going to put a 0 in that spot and carry the 1 to the next place value. Okay, so we end up with 249,000 for our number. Because 8,982 is really close to that 9,000 marker. So sometimes when we're rounding up, like in this case, if we end up with a 4-digit number that only fits in 3 spots, or a 3-digit number that only fits in 2 spots, we gotta take our 10 that we end up with and carry the 1 to the next place value. Okay, so that's what's happening there. And then what do we got? A couple of places where you can kind of see some of the usefulness in rounding. It says round each number to the nearest hundred and then add to find an estimated sum. So an estimated sum could be very useful in certain situations. I'll show you one in just a minute. But we're going to round each number to the nearest hundred to try to just ballpark what this sum is. So if I want to round this, that's a tens place, sorry. If I want to round 768 to the nearest 100, is 768 closer to 700 or 800? Well, definitely closer to 800. And then if I'm rounding here, okay, 952, is it closer to 900 or is it closer to 1,000? It's definitely closer to 1,000. So since this is closer to 1,000, but we already have 1,000 here, this is going to round to 2,000, just like in the last one we looked at. Okay, rounding here to the hundreds place, 225, closer to 200 than it is to 300. So we're going to round this to 200. And then 149 is closer to 100 than it is to 200. So we're going to round this down to 100. And now finding a sum, not so bad. So 800 and 2,000, that's 2,800. 2,800, or remember we can kind of regroup these. That's 1,000 right there. So there's 1,000 plus another 2 is 3,000. 3,000 plus 1 is 3,100. 3,100. Okay, so 3,100 is our estimated sum. Estimated sum is, again, 3,100. And let's just see, for kicks, how close we got to the actual sum. So if I took those actual numbers, 768 and 1,952 and 225 and 149, how did we do? Well, the actual sum is 3,094, and that's pretty darn close. Okay, the actual sum is 3,094, which is really close, okay? So a lot of times estimating is going to get us close enough to what we need. It depends on the situation, right? If being close or being approximate is good enough for us, okay? We can do the same thing with subtraction here if we wanted to estimate a difference. So in the next one, we're going to round each number to the nearest hundred and then subtract to find an estimated difference. So if we're going to round here, 4,725 to the hundreds place. 725 is closer to 700 than it is to 800. So we're going to call this 4,700. And then we're going to subtract, for rounding here, when we look at the next digit, after the 8 is a 7, we're going to round up. 879 is a lot closer to 900 than it is to 800. So this becomes 2,900. So 4,700 minus 2,900. Maybe you need to subtract the old-fashioned way here. If we go to subtract, that's going to be 18. And so 4,700 minus 2,900 is, how do I write this here, is, what did I say? 18? 1,800. Okay, so our estimated difference is 1,800. Okay, now again, just so we can see how close we were, let's, man, I can't even draw a line here. Let's put in our calculator the actual numbers, 4,725 minus 2,879, and the actual difference is pretty close. The actual difference is 1,846. That's not too far off, okay? So again, using the estimation is getting us pretty close to the actual number, all right? So it could be, again, a useful skill. So for example, here's a real application, all right? A UPS driver is trying to quickly estimate the total distance he travels on his daily route. Now he knows, because he's got this he's got a route listed for him. He knows that when he leaves the warehouse, he has to go 42 miles to his first stop. So what's the total distance he travels on his daily route? From the warehouse to his first stop, we say 42 miles. And then he knows that it's 9 miles to the next stop, and then 17 miles from there. And then finally he travels 33 miles back to the warehouse. So those are each of the distances that are recorded for him for his route, okay? So what we're going to do is try to approximate to help him really quickly figure out what's the total distance that he travels. Approximate. So when we round, this says to round to the nearest 10. Okay, we're going to round each of these numbers to the nearest 10. So if we're rounding to the tens place, 40 there. Here, let me list these out. Let's be real thorough here. So I'm trying to add 42, 9, and 17, and 33. Okay, rounding these numbers to the nearest 10. So in the tens place, is 42 closer to 40 or is it closer to 50? Definitely closer to 40. Plus 9, is it closer to 0 or closer to 10? Definitely closer to 10. Plus 17, closer to 10 or closer to 20? Closer to 20. And then 33, closer to 30 or closer to 40? Is closer to 30. So when I go to add these, 40 and 10 is 50, 50 and 20 is 70, 70 and 30 is 100. So we'd say this is about 100 miles. So his route is about 100 miles. Maybe this UPS driver is working in a rural place. Who knows? Maybe he only drops off to a couple of spots. Not sure. I'm pretty sure UPS drivers do a little more driving than that. But let's see how close we got to the actual. 42, 9, 17, and 33. Look at that. 101. Oh, a difference of 1. So that estimating comes in handy. Gets us close to what we want to do. Now, depending the place value you estimate to around to, you could be cutting off a lot more number and getting farther away from your actual results, but generally rounding to the tens place or hundreds place, you're going to be pretty close to your actual results. And it's a lot faster to add those estimations than it is to add the actual numbers. Okay? So there it is. Hopefully it was a good review for you. You've got some practice to work on, and if you find yourself getting stuck, then just reach out for some help. All right, guys, take care.